Right, so that's what we're going to do, but what I'd like to talk about more, and I'll come back to this now, is what it means, and this is where a lot of people run into trouble. Okay, so Excel has fitted a line of best fit, so it minimises the total square distance of each of the points from the line. So what it means is it uses a mathematical function which looks at where all the points are and finds the line that will fit them the best. The resulting equation is this thing here. Y equals 2,581.8x plus 48040. Now this first term, which is given next to the x, is the slope. And what that means is that, well, we talked about the slope yesterday. Remember, slope was up over along. It's how much something goes up when we go along one. So it's saying that for each extra thing on the x-axis, which in this case was an hour of television per week, each time we increase that by an hour, the debt goes up by $2,581.80. This is for the sample. Now, we cannot generalise from the sample to the world. What we're saying is that for these 430 people or households, this is the best line of fit, and this describes what's happening to them. When you do regression in Module 6, you will learn about how you can use statistics to say whether you can generalise that to the population. So at the moment, what we're saying, we're not saying anything about the population. We're saying that for these particular households, for each additional hour of a television is associated with an additional that amount of debt. Now, the intercept is the thing that causes the problem. Actually, before I go to the intercept, I'll just come back to this slope again. So if a family watches 5 hours more television per week than another family, we would expect them on average to owe 5 times the slope more than the other family. Now, there are questions like this in the quizzes, so what I'm expecting you to do is to look at what's the difference between the two different things, and you multiply it by the slope. So we could say for every 10 hours per week more that a family watches, their debt increases by $25,818. So you take the difference in the two values and multiply it by the slope. Now, the intercept, as I said, is a bit of an issue because usually it doesn't mean anything. It's very seldom that you can actually make something meaningful from the intercept. And the reason for that is because the data doesn't actually go through there. The data is centered around here, and so when we're talking about this part, it's reasonable to make some statements about it. But down here, there wasn't anyone who watched 0 television per week. So we can't really make any claims about it because there was no one in that range. It could be that, in fact, the people who watch no television at all owe vast amounts of money because they've bought jet skis and things like that, and they're out doing that rather than watching television. So you can't actually assume that it's going to go like that outside the range of data. Okay, so go back to here. As no one, this implies, the intercept would imply that a person who watched no television last week would owe, on average, $48,040. But it doesn't. As no one watched less than 10 hours of television, this value is outside the range of data and probably has no useful interpretation. So as a general rule, the intercept does not have a useful interpretation. People try to put it in there, but it is stretching outside what we should be doing. Okay, so let's come back to our original idea, which was, and that's what we do all of this stuff for, is to actually look at stuff. So he's saying his idea was that people who watch television frequently are exposed to many commercials which leads them to buy, resulting in increasing debt. So his theory was that more hours of television means more debt. Okay, so what we can say there is the result does seem to support the original idea that increased television use is associated with consumer debt. I guess that would be increased consumer debt for this sample. Notice it's for this sample. However, we would need to test the statistical significance of the result before we can generalise it to a larger population. And that's what you will do in Module 6. But hopefully, when you do it, this will be familiar to you and it will be easier than it might have been otherwise. Okay, that's all you need to know about graphs and stuff in Excel. Anyone who doesn't know how to get to the testing session, I'll be going over there now.